Hi everyone, and welcome to Module 2 for CHY 114. Today we are measuring we're looking at conductivity and pH. Those were all hopefully discussed pretty well in your pre-lab, and so we're going to go through the procedure today. One thing that I wanted to note for you to start off is, you know those pre-lab notebook templates that we make you do before you come to lab? You probably think, well, those are just busy work. These are just my instructors making me do something before I come. These are real things that scientists actually use in a lab. This pH and conductivity lab is one that I've been performing for years. I've been watching students perform it for years. But in order to come in and go through my procedure today, I still made a sheet of everything that I'm going to be doing. Yes, I could flip through the procedure in the manual, but that procedure in the manual doesn't do things like tell me the amount of grams that I'm going to need in order to make my solutions, and it's flipping through a whole bunch of different pages. And so what I was able to do was to take that procedure and condense it into one page of something that I can use. You'll notice that I'm not going to be using the procedure from the lab manual today at all. Everything that I need in order to complete this lab today is right on this sheet. And so I just wanted to point that out to you, that is a real thing, that those notebook templates, that pre-lab part, is something that scientists really do when they're getting ready to perform some sort of lab, is they write out things that they are going to do within that lab and within that experiment. And so let's go ahead and get started. The first thing that we have to do today is to create a whole bunch of different solutions. And so, like I said, I've already done the calculations, as you've done for your pre-lab activities, for what the mass is of the various solids that I'm going to need in order to make my solutions. The first one that I need to make is 100 milliliters of a 0.025 molar ammonium nitrate solution. And so I'm going to use volumetric flasks in order to make my solutions. Volumetric flasks look like this. I don't think we introduced those in Module 0. The whole idea of a volumetric flask is really, this little guy's only purpose for existing is for making 100 milliliters of a solution. And so you can't see it from where you are, but I encourage you to maybe just Google and look one up. But there's a little line right here, and that line marks 100 milliliters. And so what I'm going to do is mass out the amount of ammonium nitrate that I calculated I needed, which was 0.200 grams for 100 milliliters of a 0.025 molar solution. I'm going to mass out that amount, and then I'm going to add a little bit of water in here, halfway up the bulb or so. Then I'm going to pour in my actual solid, and then I'm going to fill up with water up to the line, and then at that point I will have 100 milliliters of a 0.025 molar solution. And so let's go ahead and do that. So my balance here is started and ready to go. I'm going to go ahead and zero it, tear it out, get my weigh paper, get that ready. Put my weigh paper on the balance. Tear the balance again so it's ready to go. Here I've got my ammonium nitrate solid. Hopefully some of you caught me. I'm missing an important safety element here. Let me go get some gloves. Almost forgot, and I hope some of you caught that as you were watching the video. Now I'm safe and ready to go. So here's my ammonium nitrate solid. I need 0.200 grams of that. So I'm using this scoopula. And it's very easy to overshoot. And we do want these solutions to be as close to the molarity as we possibly can. And so, almost there. right on at 0.200 grams of ammonium nitrate. And so like I said, I'm just going to add in a little bit of water now into the volumetric flask. This is not the most efficient way to do it, by the way, through this water bottle, but I'm stubborn and that's how I've started, so that's what I'm going to keep doing. So I've got a little bit of water in there now. Now I'm going to take my solid. Remember when we looked at Module 0 on ways that we use the balances? I've creased my whey paper nicely so that I can now just dump my solid in there. What I'm going to do now, you can't see it, but there's a little bit of solid left in the crease here. And so I'm just taking my water bottle and squirting that down in, keeping the crease so everything flows down into the flask. So now I have my solid in here as well. So I'm going to just now fill up to the line. I'm going to use the water bottle to just squirt down the sides, make sure that any solid that might be sticking to the sides of the flask is actually rinsing down in. Again, this certainly isn't the most efficient way, but by using the water bottle like this, it makes it easier to not overshoot my line. Because once I fill up the bulb and start getting into the neck, the water is going to start to fill fairly quickly. The one advantage I have, though, of filling it like this, just to sort of fill some time and talk as I'm filling this up, is that by using the squirt bottle like this, it helps me mix the solution as well. And so I shouldn't have to do much mixing once this is all in here. You'll note that I'm looking at eye level as I bring this up to the line. Now the meniscus is right at my line. So here's my 100 milliliters. Now I'm just going to shake this a little bit. Nothing that we use is that dangerous, so actually in order to mix this up a little bit, I'm also just going to put my thumb over the hole here and just invert this a few times. Now I have my 100 milliliters of 0.025 molar ammonium nitrate solution. I've got a selection of beakers here, which I've already pre-labeled, and so I'm going to pour everything as I make it right into my beakers. And so this is our 0.025 molar ammonium nitrate. And so I'm just going to pour it right in so it'll be ready to go for when we need to use it. And then, as always, as good lab practice, I'm just going to rinse out my flask immediately so that it is all ready to go the next time I need it. I just have a waste beaker here in front of me. So I'm just rinsing the flask out a couple of times right into the waste beaker. The next solution I need to make is 25 milliliters of 0.025 molar calcium chloride. I'm going to do the same thing. I just now have this little itty bitty 25 milliliter volumetric flask. But I'm going to go through the same procedure. I spilled a little bit of water onto my balance last time, so I'm just going to wipe that off. But I'm going to go through the same exact thing. I've already calculated that I need 0.069 grams of the calcium chloride. So I get my whey paper ready. Zero out the balance, that's ready to go. I find my calcium chloride, here it is. And I need to mass out 0.069 grams. That is not a lot, it is not going to take much of this to get there. So I'm just going to tap it fairly carefully. .070, pretty darn close. It's also good lab practice to never put chemicals back into a bottle. I accidentally did that with the ammonium nitrate, which won't be a big deal, but we don't like to put chemicals back into a bottle to avoid cross-contamination. So any leftover that I have on my scupula, I'm just going to put right into my waste beaker. Add a little bit of water into my flask. It won't take nearly as much since I'm only doing 25 milliliters of this solution. Carefully transfer my solid down in. Rinse my white paper to get all the solid in there. And then fill up to the line. Visually inspect to be sure that all the solid looks like it dissolved, and it doesn't look like it did, but I'm just going to stir it up here a little bit. There's my calcium chloride solution transferred into, again, my previously labeled calcium chloride beaker. You'll note, and some of the things here that I tell you when I talk about don't necessarily need to go in your notebook. In your notebooks, you want to be writing the things that are actually pertinent to running the procedure and running the experiment. But since you're not here live, I like to just talk about some of the various lab skills and lab procedures that are important, that you are missing out by not being able to be here. And one of the things that I wanted to mention is how important it is to be organized in a lab like this. This lab involves a lot of solution prep, and I'm going to end up here with 7 different solutions here of different materials, different molarities, and it's really important that I'm able to know which is which. And so I took about 10 minutes before I even started the video to organize myself, to get beakers ready that were appropriately labeled with the different solution types and everything like that I might need, so that when I was ready to go for the lab, it's all right here, and I didn't have to go searching for another beaker to use. I didn't have to write and label something as I'm working. I have a beaker that's labeled 0.025 molar calcium chloride, so that when I made the solution, I could dump it right in. And so then let's just move on to our next one. Now I'm making 25 milliliters of 0.025 molar sodium carbonate, Na2CO3. Here's my sodium carbonate solid. I double check the label to be sure that that is what I am looking for. And I previously calculated that I need 0.066 grams of this sodium carbonate. Oh, and I did it again. I accidentally dumped in the excess. Again, not as big of a deal in labs like this and with the experiments we're doing, but it is good lab practice to not dump materials back into their container. Quite a bit of material on the sides on this one, so again, I'm just making sure to squirt down the sides of the flask to get all of the solid down into the solution as I mix it up. Fill up to the line. Pour my solution into my previously labeled sodium carbonate beaker. The last solution that I have to make from a solid is my 25 milliliters of 0.025 molar glucose, C6H12O6. calculated that I need 0.113 grams of the solid to make this solution. Accidentally put way too much on there, put about double what I need. Here we go, 0.115, so pretty close. And there's my glucose solution all ready to go. Almost out of water in my bottle here, so I'm just going to go off camera for a moment and fill this back up. Okay, so the next thing that I need to do, so those are all of the solutions that I needed to make from a solid. I now need to take some of the NH4NO3 solution, the 0.025 molar, the 100 milliliters I made, and I need to use that to dilute some down and make 25 milliliters each of a 0.02, 0.015, and 0.01 molar solution. So again, this is where I previously calculated using our C1V1 equals C2V2 dilution equation. I calculated how much of the stock solution, how much of the 0.025 molar I would need in order to make each of those solutions. And so for the 0.02 molar solution, I calculated that I was going to need 20 milliliters of my stock solution of the 0.025 molar. So I'm just going to use a graduated cylinder here and measure out 25 milliliters of my stock solution. This is my 0.025 molar NH4NO3. So I'm measuring 20 milliliters of this in a graduated cylinder. Now I want to get as close as I can, so I'm going to fill close to the line just by pouring it in, but then I'm going to use a pipette just to get myself up to the actual line. So there's our 20 milliliters. Again, I'm looking to make 25 milliliters total, so I'm just going to pour this in to my 25 milliliter volumetric flask. Carefully, because this is a small opening in my flask here. If I can do this without spilling it all over the place, I will be impressed. There. And I just want to make sure that I get all of the solution in here, so I'm just going to rinse the flask down with a little bit of water. Or sorry, rinse the graduated cylinder with a little bit of water. And then pour that into, just to make sure that I got all of that initial stock solution. I'm still well below my line, so that's good. And now I'm just going to use my squirt bottle and fill up to the line. Here. So again, what I did is I took 20 milliliters of the 0.025 molar NH4NO3 and I diluted that up to 25 milliliters. So I took 20, diluted it to 25. Invert that a couple of times, and now pour the solution again into my previously labeled 0.020 molar NH4NO3 beaker. And rinse out my volumetric flask for the next solution. The next solution I need to make is my 0.015 molar NH4NO3 solution. For that, I calculated that I would need 15 milliliters of my 0.025 molar solution. So I'm just going to use my volumetric my graduated cylinder and measure out 15 milliliters of my stock solution. Pour that 15 milliliters into my volumetric flask. And again, just rinse out my flask here a little bit and make sure that I'm getting all of the stock solution that was actually in there. And then fill up to my 25 milliliter line. Last solution is my 0.010 molar solution. So I need 10 milliliters of my stock solution for that. Measure 10 milliliters of the stock solution in the graduated cylinder. Pour that 10 milliliters into my volumetric flask. Rinsing out my graduated cylinder. And finally, fill up to the 25 milliliter line. And that's all of the solutions that I need for the conductivity portion of Module 2. I have 0.025 molar NH4NO3. I also have 0.02 molar, 0.015, and 0.010 of my NH4NO3. So I have all of my NH4NO3 solutions. And I also have 0.025 molar, 25 milliliters of 0.25 molar CaCl2, Na2CO3, and C6H12O6. So those are all of the solutions that I do need to now go on to measure the conductivity, which we will do in the next video. I really need to find a way to get my remote to actually work all the time. So I'm just going to walk over and stop the video.